everyone. So today our team will be discussing one of the topic of statistics and probability, which is the normal distribution. So Miss Brelyn Pulido will be discussing the introduction of our topic.
Normal distribution. One of the most commonly observed continuous random variable has a bell-shaped probability distribution. It is known as a normal random variable, and its probability distribution is called normal distribution. The standard normal distribution has two parameters, the mean and the standard deviation, that will be discussed later.
A standard normal distribution is a special normal distribution whose mean is 0 and whose standard deviation is 1. The normal curve with mean is equals to 0 and the standard deviation is equals to 1 is called the standard normal curve. The corresponding distribution is called the standard normal distribution. The random variable itself is called the standard normal random variable and is commonly denoted by Z.
Of normal probability distribution. Number 1. The normal distribution curve is bell-shaped. Number 2. The median and mode are equal and located at the center of the distribution. Number 3. The curve is symmetrical about the mean. Number 4. The total area under the curve is 1 or 100%. And number 5, the curve is asymptotic to the x-axis. And here's the picture that I'm talking about.
The empirical rule, the 68, 95, and 99.7 rule tells you where most of your values lie in a normal distribution. Around 68.2 of values are within one standard deviations from the mean. Around 95.4 values are within two standard deviations from the mean. Around 99.7 of values are within three standard deviations from the mean.
Areas under the standard normal distribution. In finding the areas under the standard normal distribution, we need a Z-table. Look at the Z-table for the given Z-score by finding the intersection. But note, on using the table, in order to look up the Z-score in table, you have to split up the Z's value at the tens place. For example, to look up 1.32, you would look up 1.3 and then look at 0.2. Since the example for a visual on what finding the intersection looks like.
Now, we're going to find the area to the left of Z-score 1.49. As discussed by Mapalad, we have to split up our mean value at the 10th place. So first, we will look up to 1.4 and then look at 0.09 and look at their intersection. So the area to the left of Z 1.49 is 0.9319. Here's another example. So we have here Z 1.10, look up to 1.1 and then 0.00. Their intersection is 0.8643, which is the area of Z 1.10 to the left.
After finding the area to the left, we are now going to find the area to the right. So, we have here an example, Z 2.10. We are just going to repeat the steps. Look at the 2.1 and then 0.00. and find their intersection. So the area of Z2.10 is 0.9821. Another example is Z3.21. Look at 3.2 and then 0.01 and find their intersection. The area to the right of Z3.21 is 0.993.
The z-scores. Area under the normal curve are given in terms of z-values or scores. Either the z-scores locates x within a sample or within a population. Here is formula for calculating z. Here is for population data and here is for sample data. Whereas z is standard score, x is for row score or observed value, mu for population mean, and sigma for population standard deviation, x bar for sample mean, and s for sample standard deviation.